Hello students, in this video we are going to see about planetary interiors. And when the planet formed, they were very hot. This heat came from three sources. Number one is accretion, which is nothing but impact from asteroids and comets, and differentiation, heavy material sinks, light material rises, and radiation, radioactive materials. And this is the interiors of Mercury, which contain iron or nickel core and rock siliconates. And Venus have iron or nickel, same iron or nickel core and rock siliconates, and Earth have also iron or nickel core, and then Mars, the four terrestrial planets have the same core and then siliconates. And these are the differentiation caused the heavy materials such as iron and nickel to sink towards into the core. The lighter material rose to the surface and cooled, forming the crust. So the heavy materials like iron and nickel are tightly bounded and produces heat to the core, and then this heat produces the magnetic field to the planet. The interior heat of the planet derives earthquake, volcanoes, etc. because the core itself emits the heat. All the planets are cooling down. The smaller the planet, the faster the planet cools. How much the planet surface be like, so it depends on the cooling factor of the planet. Earth still has a hot interior. Mercury's interior may have cooled completely. These are the summary of the terrestrial interiors. The Mercury has a large iron core, about 3,500 kilometers in diameter, which is 60% of its total mass, surrounded by a silicate layer, which is about 700 kilometers thick. This core is probably partially molten. And this is the comparative interiors for four terrestrial planets. This is Mercury have a small solid core, and then no liquid iron core, and Mars have the silicate mantle, solid iron core, and then silicate crust. The Earth having all three details. First one is solid iron core, and then liquid iron core, and then silicate mantle. Finally, Earth have silicate crust. And like us, Earth, Venus also have these four materials, but comparatively Earth, the Venus have highest thickness of the silicate crust. The Mars has a solid iron and sulfide core, which is about 2,600 to 4,000 kilometers in diameter, surrounded by a silicate mantle and rocky crust. Venus interior is like a Earth, except iron nickel core probably makes up a smaller percentage of its interior. Summary of Jovian interiors. Jovian planets means Jupiter to Neptune. Jupiters have hydrogen and helium atmosphere that is about 1,000 kilometers thick and merges smoothly with the layers of liquid molecular hydrogen, which is 20,000 to 21,000 kilometers thick, and then pressure is also near liquid metallic hydrogen layer about 37 to 1,000 to 38,000 kilometers thick. Probably has a silicate ice or core twice diameter of Earth with 14 times Earth's mass. Certain is smaller version of Jupiter, silicate core about 26,000 kilometers, and then ice layer about 3,500 kilometers, and beneath the ice layer to about 12,000 kilometers thick of liquid metallic hydrogen. Then liquid molecular hydrogen about 28,000 kilometers thick. Comparison on Uranus and Neptune, probably not enough to liquid hydrogen, and Uranus Neptune have silicate core about 8,000 to 8,500 kilometers in diameter, and mixed with ammonia and methane about 7,000 to 8,000 kilometers thick. At top, 9,000 to 10,000 kilometer atmosphere of helium and hydrogen. And this is the comparative planets interior for the Jovian planets. And Neptune have the silicate core, and then ice core, and finally gaseous hydrogen. And the Uranus have silicate core, and then ice core, and then highly increased gaseous hydrogen. And when compared to Saturn, Saturn have a silicate core, and then ice core, and liquid metallic hydrogen, and then liquid hydrogen. Finally, Saturn have gaseous hydrogen. And when compared to Jupiter, silicate core and the very enormous amount of liquid metallic hydrogen, and then liquid hydrogen. Okay, these are the Jovian planet's interior to this some same scale. Now, summary of the planetary interiors. Makeup of planetary interiors is dominated by physics of materials under high temperature and pressure. Because this high temperature and pressures form the core, and it also provides the heat and magnetic field to the planet. Starting with the cold, low pressure region, rocky materials are solid. As one goes deeper into a planet, temperature and pressure rises. Solid becomes semi-solid because it melts, and plastic-like materials. With higher temperature and pressure, semi-solid becomes liquid. With even higher temperature and pressure, liquid or molten rocky materials undergo a phase change and become solids again. This is why the very thinner cores of the Earth and the Venus are solid, surrounded by liquid outer cores.